Rightio, so here talking about points of inflection and looking at the nature of points of inflection, when they occur and how do we identify whether a point of inflection occurred and where does it occur. So the first thing about a point of inflection is we've used it before with turning points or stationary points, but it's a point where the concavity changes. So concavity, you'll remember, is that U or N shape. So when it changes from being a U to an N, that's when a point of inflection occurs. So if we were looking very briefly at that sort of function, okay, it would occur, that's obviously got a different concavity to our shape up here, okay? So at that point there, our concavity has changed, and that is called our point of inflection. As concavity is determined by, so if we think back to our last lesson about concavity and how we determine concavity, it's determined by the positive or negative nature of our double derivative, double dash x, or d squared y dx squared. So this occurs when our double derivative goes from positive to negative or vice versa. So we have to think about, when does a number go from negative to positive? What's that point along a number line? Let's go right back to year 7. What point between a negative and positive occurs? And we obviously know that occurs at 0. So our double derivative, when it equals 0 and is transferring from a negative to a positive value or vice versa, that's how we know the concavity is changing, and therefore we have a point of inflection. So rather than talk too much about that, I'd rather show you an example of how we can do that, and a pretty special example. Okay, this won't come up very often, but I'm going to show you a very special example of that, and that can be found in question 7 of exercise 6.3. Okay, which I'm going to go through now as an example. So the function fx is x to the power of 4 minus 4x. So before I go through any of these problems, if I know I'm dealing with concavity and that sort of thing, I just go straight in before I've even looked at the question really deeply and derive it and then double derive it. Okay, so I can see that my derivative there is 4x cubed minus 4. Okay, and that would make my double derivative 12x squared. So then from there, I think question 7a says something along the lines of determine the stationary points or the turning points and their nature. Okay, so the first thing I would do is, let's say for A, I want to find when f dash x equals 0. So 0 equals 4x cubed minus 4, which I can take a factor of 4 at the front. 4 equals x, 0 equals 4 times x cubed minus 1. Again, the only thing in that function that can equal 0 is the x cubed minus 1. 4 times 0 will give you 0. So I know that x cubed minus 1 equals 0, which means that x cubed equals 1 and x equals 1. So I know that my stationary point occurs at x equals 1. Now I need to determine the nature of that stationary point. As you can see, when I shove 1 into f double dash x, I will get 12 times 1 to the power of 3, which is just 12. And again, I don't care about the size of that number. All I care is that it's positive, okay, which tells me that at the point x equals 1, I have a minimum. I'll probably also need to find the y value for that, but I'll come back to that later. I don't need to find the y value right now. I can do that later on. So then what I want to do, okay, so I'll just shift this over here. Then what I want to do is to, it says, how do you know that there is no points of inflection on that? So the first thing I like to do is see if there's a point where f double dash x equals 0. So f double dash x equals 0 is what I'm looking for B. Now 0 therefore equals 12x cubed, squared, squared. Now there is only one point where that will equal 0, and that will equal 0 when x equals 0. So you're probably thinking at this point, well, f double dash x equals 0, therefore there needs to be a point of inflection. However, if we look at the double derivative function 12x squared, I want you to think about the fact, does that ever go to a negative value? So is it possible to put any value of x in? You can put any value of x in. Is it possible to get a negative value? A negative value squared is a positive value, a positive value squared is a positive value. Therefore, because it doesn't change sign at any point in time, we haven't got a point of inflection. Okay, so because the number the f double dash x never is negative, there is no inflection. Clear with that? Now we move on to C. Now C is asking us to, what is C asking us to do? C is asking us to find the key features and intercepts and then sketch our function. So the first thing, we're going back to this function here, fx. I want that to equal 0 because that's where my x-intercepts occur. Okay, so 0 therefore equals 4. No, it doesn't. It equals x to the power of 4 minus 4x. Again, I can take a factor of x out the front, and I get x to the power of 3 minus 4. Now that will equal 0 in two scenarios. When x equals 0, or when x to the power of 3 minus 4 equals 0. So either x equals 0, or I'm just going to do this quickly, x equals the cube root of 4. Okay, which is a little bit more than 1. I'm going to need to come back to our middle board here, because I'm going to draw this in a second. I don't need any of those functions anymore. So if I'm getting my graph up here, I know that I've got a point here, let's just call that 1, and a point here we'll call 4 root 3. Okay, I know that at those points my function is going through. I need to obviously find a few more points. So I identified earlier that we've got a stationary point occurring at 1 somewhere. I don't know where it's occurring, but I do know it's a minimum. So to find out what that value is, I let 1 be subbed into our fx function, which is x to the power of 4 minus 4x, which equals 1 minus 4, which equals negative 3. So now I know that this point here equals negative 3. Realistically, I don't care about what's happening beyond that point. I just want to connect those dots. Now, because I've only got one turning point, one minimum, I can assume that everything beyond that point is going to look something like that. It's going to turn at this point here and shoot up in that direction there. That's what our function looks like. Okay, that's question A, B, and C answered very simply. Being very aware of the fact that our point of inflection occurs when f double dash x equals 0, providing there is a change between our signs. So it has to go from positive to negative or negative to positive, which almost always occurs when f double dash equals 0, but you do need to be careful.